Hello everybody and welcome to my library database presentation. This library database is for a local library that was in need of keeping track of the inventory of their films and books as well as their member information. What we used to build this database was SQL. SQL stands for Structured Query Language, and although it's a querying language, it's not too hard to understand. As you can see here, we mainly just used create table statements and insert statements to create the entire tables filled with data and information. So let's see the members table for specific. We just use create table members library card number, which is an integer, and we initiate it as a primary key, which is basically a unique identifier to find a specific member. There's going to be a first name column that's going to consist of a text variable, a last name column with the text variable, address with the text variable, phone with the text variable, overdue items is going to have an integer variable. And to insert data into these tables, what we would do for each specific column is one is going to be the first user with the library card number. So his library card number is going to be one, and this user's first name, this user's last name, user's address, user's phone, and zero since this user has not checked out any books. So this database is going to consist of 5 tables. It's going to be the books, checked out films, and a members table. For the books table, it's going to consist of a book number, book ID, title, author, publisher, genre, availability, and library card associated with availability if the availability is set to no. For the book number and book ID, the book number is the primary key for this table because it's the unique identifier. But the book ID is the secondary key because it is also a unique identifier. There's probably going to be eventually a book with the same name, so we're going to need something to find a specific book because using title to search for specific books would not be as effective as just giving it unique keys such as book number or book ID. So once an availability is sent to no on books table, it gets sent to the checked out books table. So what the checked out books table is going to have is the book ID, the title of the book, author of the book, publisher of the book, the library card number associated with the book checked out, as well as a checkout date and a check-in date. Once a user checks out a book, they have 2 weeks to check it back in. So let's say for American Sniper, member number 4 checked it out on 4/29/2021. They have now gotten to check, or they now have to check it out or return it on 5/13/2021. Films table is basically really similar to the books table, but it just really works with films. The film number is going to have a specific key, a unique key, and a unique film ID with a film number and film ID. It's also going to consist of a title, director, studio, a genre, availability, and a library card if the availability is set to no. This is going to be similar to the checked out books table since it's going to have a film ID, title, director, studio, library card number, checkout date, and check-in date. This is going to be the members table. The members table is going to have unique identifiers since having a first name or a last name as a unique identifier wouldn't be really effective. Since as you can see between library member 3 and library member 6, they both have the first or the same first name. For films relationship, this is going to be the relationship between members, films, and checked out films. What the members are going to do is check out a film, and once that film is checked out, there's going to be availability change that gets sent to the checked out films table. And the films table is going to have a 0 to many relationship with the checked out films table because there could be either 0 films that are checked out or many films that are checked out. But for a film film to be checked out, it needs one or many films to actually be sent or actually be consisting of a data. Same with the checked out films. The checked out films for a film that's checked out, it can only have one member associated with it, but a member can have 0 or many films that they checked out. It's going to be the same thing here with the books relationship. The member checks out a book and the book's availability changes, and they're going to have the same relationships basically as the films table. What are some useful queries that we used in order to help the librarians keep track of their database and manipulate data in an important way? Well, this is the automatic inventory updating query. Well, what this is going to do is automatically insert books from the books table into the checkout books table where the availability is set to no. So the librarian's database manager, whoever is looking at this library database, they don't have to worry about automatically setting a book to the checked out books table. They could just have this set up and it'll do it for them. This is the overdue items query. Let's say there's a member with a lot of overdue items and the book needs those, or the library needs those items back. What this is going to do is select all from them for members where the amount of overdue items exceeds the number of 2, or any number they would like to set it to. This is the genre finder query. This is going to select all films or all from films where genre equals documentary. So all the documentary films that we got are will pop up with this query. You could also do this with books. You're just gonna have to do select all from books where genre equals whatever genre you would like. Say horror or something. This is going to be a studio finder query. Let's say you wanted to see an old Disney film. What you would do is select all from films where studio equals Disney. This is going to really help find specific studios behind each film and have libraries really find specific pieces of information that they need. This is the members checked out items query. Let's say you wanted to find the specific items that a specific member checked out. You do select all from books and films where the library card number equals 4, or any number for the library card number you want associated to find all of their checked out items. So let's say you wanted to find the information or the books and films that user 8 would check out. You would just set library card number equals 8. Summary. SQL can be incredibly useful when creating a database. Not only is it a language that's easy to understand, but it provides many useful features as well. Utilizing SQL can really help maintain and manipulate data in a way that's completely in your control. Thank you all for watching this presentation, and I hope you guys all have a great summer.